Sorting algorithms. What is sorting? Sorting is the process of arranging elements in a specific order. So, you generally arrange in ascending or descending order. Why should you do this? Why should you arrange in ascending or descending orders? Or why should you sort? What is the importance of sorting? You should arrange because sorting many times makes many other processes easier. So it may be you want to search on your data set, or maybe you want to analyze your data set, or maybe that you want to run any algorithm on your data set. Many times it so happens that working with sorted data sets will be much easier than working on unsorted data sets. See, even in our search lectures, we already covered a lot of search algorithms. And in all those lectures, you would have noticed one thing. Linear search is the only search technique which worked well on unsorted datasets. All other search techniques required sorted datasets. So similarly, when we go forward in algorithms, when you see more and more algorithms, you will understand that many of them require sorting as a prerequisite. So in order to run an algorithm, you would require sorted data. So this is why sorting forms the core of algorithms, and mainly sorting is of two types. One is comparison based sorting, other one is non-comparison based sorting. So in order to understand this, let us take an example. Let us say this is your data set 5, 7, 13, 2, 1, 10, 20, something like this. This is your data set. In comparison based sorting, what you do is you directly compare the elements in order to understand which one is smaller, which one is larger, and how should you place these. So if you want to compare 5, you will directly compare 5 with whatever element you want to compare with. So if you want to see whether 5 is in the right position with respect to 7, you will directly compare 5 with 7 and see that yes, 5 is smaller than 7. So it is correctly placed on the left side of 7. So this is what is called comparison based sorting. So many of the sorting techniques are comparison based. That is, you will directly compare elements with other elements in order to understand the position of those elements, whether you should keep this element on the left side of it or the right side of it. These are called comparison based sorting. What about non-comparison based sorting? Though we do not directly compare elements, but what exactly do we do there, that we'll clarify whenever we reach non-comparison based sorting. So we'll go through all the non-comparison based techniques as well as all the comparison based techniques that are mainly used. So there it will be very clear for you what exactly happens, right? So in comparison based, you have a lot of algorithms, sorting algorithms like bubble sort is there. You have selection sort, you have insertion sort, then you have many more like merge sort is there is quick sort, there is heap sort, then what else? Shell sort is there, tree sort is there, then you have tim sort. We'll go through all these sorting algorithms. Through all these, we'll separately go in different lectures and we'll clarify what exactly is happening in each of those sorting algorithms. And in non-comparison, you have algorithms like counting sort, then you have radix sort, you have bucket sort. So these are all non-comparison based sorting algorithms. So keep in mind that sorting is many times a prerequisite for many other algorithms. Because of that, we'll go deeply into sorting, we'll understand all sorting techniques. And the point is you need to know under what circumstance should you use which sorting technique. Once you know this, you are clear with this, then you are good with sorting. Okay.